Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, tonight I want to take you through exponents, particularly for grade 8 and 9. Here is my YouTube channel ID. You can go to YouTube, then you type at Kangaroo Maths and Science Academy. Then you'll find all the videos that I've already created. And kindly don't forget to like, subscribe, and hit the bell notification for future video updates. Without wasting time, ladies and gentlemen, let's start with the learning objectives. Then at the end of the session, grade 8 and 9 learners must be able to define the term exponent, must be able to know what do we mean by an exponent, and also they must be able to know the notations of an exponent, and they must also be able to know the laws of exponent and how to use these laws in solving problems, and they must also be able to know or to solve exponential equations. Right. Number one, let's now start with the definition of an exponent. Number one, a learner must be able to know what is an exponent. So let's start with the definition of an exponent. Right, what is actually an exponent? Right, an exponent let me just use, exponent refers to the number of times, how many times? It refers to the number of times a number or a variable. It can be a number or it can be a variable is multiplied. It is multiplied by itself. So an exponent is the number of times, or refers to the number of times a number, or a variable is multiplied by itself. How many times a number or a variable is multiplied by itself? That is called an exponent. Let's do an example to actually explain more about this exponent. Consider a number. Let's say we have the following number. Let's say we have, as an example, let's say we have, let me just use black. Let's say we have 2 multiplied by 2 multiplied by 2. Now, if you look at this, we know 2 multiplied by 2 multiplied by 2 here, the answer is 8. But now we want to talk more about exponent. An exponent refers to the number of times, how many times a number or a variable is multiplied by itself. Look at this. We are taking 2, we are multiplying with 2, we are multiplying with 2. You see that we want to look at how many times are we multiplying this number by itself. So we look at this. Now we used 2 initially. 2 we multiplied by another 2. We multiplied by another 2. So 2 multiplied by 2 and also 2 multiplied by 2. Now the question is, how many times did we multiply this 2 by itself? How many times can we multiply a 2 by itself? Okay, just a minute, guys. Okay, so here we want to check how many times can we multiply a number by itself. Look at this. 2 multiplied by 2 multiplied by 2. How many times did we multiply this 2 by itself? Obvious, the answer would be 3 times. So now we're going to say, okay, fine. We're going to write these as 2, but at the top we'll write 3. What does this mean? It means we have multiplied 2 by itself. How many times? 3 times. So it means that 3 there, it's called an exponent. This is called an exponent. It's called an exponent. So an exponent refers to the number of times a number or a variable. Why am I using variable? A variable because it can be any unknown quantity. It's not about using number only, but here it's telling us the number of times a variable or a number is multiplied by itself, which means this 3 it's actually called an exponent. It's called an exponent. So which means we can still have another questions like this. Let's say we have this. Let's say we have as an example, now we're having, okay, let's say we have 4 by 4 by 4 by 4 by 4. Then we know what is the answer for this. What is the answer for this? Now, if we want to write this, this will be, we have to count, look, we are multiplying 4 and by itself, but the question is, how many times are we doing that? So to count the number of times, it means we're going to say, okay, fine, it's 4 by 4, 4 by 4, 4 by 4, 4 times 4, which is the same as 4. We're just taking 4 here, then we count how many times are we multiplying this 4 by itself. So what would be the answer? This will be 4, but how many times? 1, 2, 3, 4, 5 times. So which means this 5 is actually called an exponent. This is an exponent. So it means when we are dealing with exponents, we are dealing with a number that is raised, or we just say a number that is multiplied by itself, like looking at the number at the top there. So this is the one that is telling us that we are dealing with an exponent. Now, the question is, since we know what is an exponent and we are able to represent it, okay, just a minute. Let me try to erase this one so that you must not keep on writing. Okay, so this, it means this will be 2, and at the top will be 3. Remember I said 3 here is our exponent. 3 is our exponent. Now we know that, okay, a number of times a number is multiplied by itself, that is called an exponent. So now we can say, let's now look on a case where we have, let's say we have x, then with a 10 here. So what does this mean? It means this x, which is called a variable for now, but it will have a name. Why it's a variable? Because it's just an unknown quantity. It can like, it's not fixed. It can be, we can use any number. But now, which means when we are given this, we can expand these as, it means now we need to know how many times can we multiply this x. So it means it's telling us that we have to multiply x by itself 10 times, which means that 10 is actually called an exponent. The 10 is our exponent because it's telling us how many times can we multiply the x by itself. So it means we know that we have an exponent. So this will be x times x times x times x times x, 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 and x, and x. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have to expand these 10 times so we know what is an exponent. It's telling us how many times can we multiply the x by itself. It can be a number or it can be a variable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Imagine when we have this, let's say we have a to the a with 3 at the top. What is our exponent? Our exponent is 3. So what does this mean? It means this 3 is telling us that if we want to write this a, we can repeat the a, we can multiply the a by itself. How many times? 3 times. 3 times. Remember, I can use dot to represent multiplication. You can either use cross or dot to represent the multiplication. So it means I can repeat the a how many times? 3 times, which means it's telling us the number of times we can repeat or we can multiply the number or the quantity by itself. Now we are able to know what is an exponent. Now, since we know what is an exponent, now we can move on to the notations of an exponent. How do we actually write exponents? Let me take it like let me call this n. The notations of an exponent. Right, when you are dealing with an exponent, it means an exponent should always be raised to the power something. Right, that power is actually called an exponent. So now the question is, imagine we have this, we say a with an n there. So what does this n represent? The n, as I said, it represents the exponent. We're going to call this an exponent. So this is our exponent. But in other book, these exponents, we actually call it a power or an index. In other book, they call it an index. But this one, this quantity here is called a base. So we have a base a and we have an exponent of n. So how can we pronounce this? How can we pronounce this? To pronounce this, it means you're going to say, here we have a, the base a raised to the exponent, a raised to the exponent of n. So it means you can use the word exponent, or we can say a raised to the power of n, or we can say a raised to the index n. So it means we use the word index, or we use the word power, or we use the word exponent interchangeably so. So it's either we say a to the exponent of n, or we say a raised to the power of n, or a raised to the index n. So this is what you need to be able to know when we're dealing with exponent. And you must be able to know which one it's a base and which one it is an exponent. Right. Let us now go through what we said earlier. We said an exponent is the number of times a number or a variable is multiplied by itself. That one, I believe you know it. Then again, we've seen that if we take 2, we multiply by 2, we multiply by 2. Here we have to count that, okay, we are multiplying 2 by itself, but the question is how many times? 3 times, which means the 3 there is regarded as an exponent. So if you're multiplying 4 by 4 by 4 by 4, but by itself, how many times did we multiply that? 5 times, which is the 5 is our exponent. Now I believe you know which one is the base and which one it is the exponent. Now, for example, if you look at what we said here, we said x to the power of n, or x raised to the power of, I'm going to say 10. What is the 10 here? 10 is our exponent, or our power. We can call it a power or an index. Then this one x here, which is now a variable, is called a base. So this is the base, and this one is an exponent. So a here, it's also a base. It's also a base. And this one is an exponent. exponent. So you must be able to know that when you are given an exponent must have the base and must also have a power or an index or an exponent. We just call it an exponent because of this number. Okay. Now, now it means you are now able to know, to identify which one it is an exponent and which one it is a power or an index. All right, I want us to move on. Let us now move on and talk about what is this? The laws of exponents. The laws of exponents. And guys, you need to be able to know this. Number 3, we need to talk about, okay, let me use the permanent so that I must not keep on erasing. Okay, so we need to talk about the laws of exponents. Okay, let me close this one. Right, let me use, okay, then change the color. So number 3, we have what you call the laws of exponents. This is for grade 8 and 9, laws of exponent. Remember, as a notation, what did I say? I said if we have a to the exponent of n, or a to the power of n, then which one is the base? Already the base here, it is the a. The a is the base. And which one is an exponent? The exponent is the x. So remember, the x is telling us how many times are we multiplying a by itself. I think we went through this example to say when we have 2 with 4 here, we know 4 is our exponent. It's telling us the number of times we can multiply the base by itself. So which means the base here will be 2. So we're multiplying 2, but how many times? 4 times. So I believe you are following. All right, let's now talk about the laws of exponent. Now I'll start with the first law. Let's call it law number 1. It's very important to know the laws in order to enjoy. Okay, let me call this law 1. The law number 1, it says, this is called the multiplication law. Let me just call it multiplication law. It says, if you have 2 base, let's say you have a to the exponent of, let's just say x. You multiply this with a to the exponent of y. Sometimes we'll use this or we use this, a dot ay. So this means the same thing. This just represents multiply, product or multiplication. Or another way we can use brackets. Brackets can also represent multiplication. Instead of putting dot or a cross, we can even use this. We can also say a to the exponent of x in the brackets. In another bracket, then we say a to the exponent of y. So this is also the same as multiplication. Now, according to this law, it says, when you are dealing with multiplication of exponent, as long as the base are the same, when you are dealing with multiplication, what you do, you take one base. What is our base? Our base here is a. And you add the powers of the exponents. So we only do these when we are dealing with multiplication. As long as there is multiplication in between, when the base are the same, you take one base take a base and you add exponents. I believe you know which one are exponents. So you take one base and you add exponent. Take one base and you add the exponent. By the way, which one is our base here? From the first one, our base is A. Which one is the exponent? The exponent is X. Same applies, we still have here, this is an exponent. And what is our base? Our base is the A. So what do? You take a base and you add exponent. You take one base and you add the exponent. This is according to the first law, laws of exponents. So now why are they saying when we have multiplication, we must take one base and add exponent? Here is the answer. Imagine we have this. It's just an example. Imagine we have this. We have, okay, let me just use a number. Imagine we have 2 to the exponent of 3. Just an example. Imagine we have this. Okay, let me just use, because will take more time. Okay. Okay. Okay, here it's an example. Imagine we have 2 to the exponent of 3. We are multiplying with 2 to the exponent of 2. Now, if we were to expand this, we'll say, okay, fine. 2 to the exponent of 3. Remember, this 3 is our exponent. So it's telling us how many times can we repeat this 2. So it will be how many times? 3 times. So it will be 2 by 2 by 2. Then times again. How many times? Because we still have another exponent here. How many times can we repeat this 2 by itself? It will be 2 times, twice. So you see that this one is telling that we have to repeat it 3 times. And this one, it says you need to repeat 2 times. So, but you see that here we are still using the same numbers, 2 by 2 by 2 by 2 by 2. So how many times can we repeat this number as a whole? So it's 1, 2, 3, 4, 5. So the same as 2, 5 times. You see that this is now an exponent. So without having to do this, it says when we are, here we are using the law. When we have 2 to the exponent of 3, we multiply by 2 to the exponent of 2. Without having to follow this route, we have to say, okay, as long as the base are the same, remember what is the base here? Our base is 2. So the law says, as long as the base are the same for multiplication, what we do, we just take one base and we add the exponent. So it will be 3 plus 2, and this gives us 2 exponent 5. You see that is the same as that one, without having to expand one by one. Let's use this law. Imagine when we have, let's say we have 2 to the exponent of 8, we multiply by 2 to the exponent of 5. We want to use this law, x to the exponent of 3 dot x to the exponent of 2. Now, another one, let me write another one here. Y to the exponent of 10 dot y to the exponent of 2. And another one, x to the exponent of 3 and x to the power exponent of 5. Now, look at this. I said under multiplication, it's either we use a cross or we use a dot or we use bracket. It's also the same as multiplication. Now, according to this law, it says as long as the bases are the same, we just take a base and we add exponents. So what is our base here? What is the base here? The base is 2. What is the base in the second one? The base is x. What is the base here? The base is y. And what are the base here? The base is x. As long as there are multiplication in between, what to do? We take one base and we add the exponent. So we're going to add 8 with 5, 3 with 2, because there's multiplication, 10 with 2, 3 with 5. So it means the final answer here, it will be how much? It will be 2 to the exponent of 13, which is the same as we can say we are repeating 2 8 times and 2 5 times. All in all, there will be 13. So this one will be x to the exponent of 5. This one will be y to the exponent of 12. And this one will be x to the exponent of 8. Remember, we use this law number 1 only when there is multiplication. Only when there is multiplication. But if, let's say, we have x squared plus x squared, can you say this is the same as x to the power of 2 plus 2, which is equals to x to the power of 4? It's just my question. The answer is no. Why? Because there is no multiplication. So it means the law applies, is true when we have multiplication. So this is not the same. It's not true. We'll talk more about this. This is the same as 2x squared. We'll talk more about that when we are dealing with algebraic expressions. So you need to be able to know when do we use law number 1. Remember, law number 1 works only when we have multiplication and only when the base are the same. If the base are not the same, you cannot use law number 1. I believe you are following. So now I want us to move on to the second law. I believe you've seen how do we deal with law number 1. When the base are the same, we take one base and we add the exponent. That's why in mathematics, exponents are very important. Where we see brackets, 2 brackets, a pair of brackets, usually there's a multiplication between, or a dot or a cross. It's just representing multiplication. Now we're going to move on to the second law. Let me use this because I don't want to keep on erasing. Okay, let's call this law 2. Law number 2, which you call it the division law. The division law says if we have a base that is an exponent, let's say we have a base that is an exponent, with this time around we divide by the base a with the exponent, different exponents. Remember, this is the same as when we have a to the exponent of x divided by a to the, so it's on the same thing. Whether we're writing it like this or like this is the same thing. It's just representing a division. So according to the law of division, it says when we are dealing with division, as long as the base are the same, you take a base or you take one base and subtract the exponents. We take one base and we subtract the exponent. We subtract the exponent. How do we subtract the exponent? It means what you do, we just say, okay, fine. What is our base? It's A. So what you do, we look at the exponent. The exponent here, it's X, and is exponent Y. So we subtract them. We take the one, the numerator, which is X. We subtract the one at the denominator, which is Y. Why are we doing this? The question is, why are we saying when the base are the same for division, we take one base and subtract? Let's do an example. Consider this example. Let's say we have 2 to the exponent of 5. We're dividing this by 2 to the exponent of 3. 2 to the exponent of 5 is the same as, remember, what is this? This is an exponent. It's telling us how many times can we write this 2 by itself. So it will be 2 by 2 by 2 by 2 by 2. How many times? 5 times. Then divide by, this is 2 by 2 by 2. How many times? 3 times. Now, look at this. We know that in multiplication, like for example, 2 divided by 2, the answer is 1 because 2 divided by 2. 2 into 2 goes once. So which means here we can do this, we can say, okay, fine. 2 into 2 goes once, 2 into 2 goes once, 2 into 2 goes once. So what are we remained with? We are remained with 2 by 2. And which is the same as this is the same as 2 to the exponent of 2, because this is telling us how many times can we repeat a number by itself. But now the question is, imagine having to do this when you have, let's say you have this, it's just an example. Let's say you have 2 to the exponent of 20. Then you have to divide by 2 to the exponent of, let's say, 9. So it means you have to repeat 20 times. It's going to be a tedious work. Because if you have 100, then you have to do it 100 times. Imagine you have to do this. 2 times 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 2. So many times. Times 2 times 2 times 2 times 2 times 2 times 2, and so on. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Imagine you have to do 20 times. Then divide these by how much? Remember, like there's still another one. I don't want to keep on writing times 2 and so on. So this will be 2 times 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 how many? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you see that if we have to do this, it will be a tedious one because 2 divided by 2 goes once, 2, 3, 4, 5, 6, 7, 8, and 9. So how many times are we going to be left with? It will just be 2 times 2 times 2. How many times? 11 times. Imagine having to write this, to say you have 2 times 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 2. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, which is just how many times? 10 to the power 11. Imagine having to do this all the time when you are writing exponent. It will be a tedious work. So to avoid having a tedious work, it means now we need to follow this law of division to avoid doing this time and again. So it means with to avoiding this, imagine having to do this time and again. I'm not saying it's wrong, but imagine having to do this. So to avoid that means you must say, okay, fine. From now on, wherever we have the same base for division, what do? We take one base, which is 2, and we subtract exponent. So we start with the one at the numerator, which is 5. So we're going to have 5 minus 3. 5 minus 3, and gives us how much, guys? it gives us 5 minus 3. This gives us 2 to the exponent of 2. You see that we got the same answer as this, but we used a shorter approach. The second one, imagine when we have this 2 to the exponent of 20, dividing it by 2 to the exponent of 9. How do you deal with this? The base are the same. We just take one base and we subtract exponent 20 minus 9. Obvious 20 minus 9 will give us 11. So you see that 11 is an exponent. So it means we got the same answer, but did not use a long approach. So it's very important for a grade 8 learner or a grade 9 learner to be able to know exponents. Exponents are very important. Right, remember, practice makes perfect. Let us now move on to the law number 3. I want to talk about this. The law number 3. Okay? Law 3. We're now focusing on exponents only. Right. The law number 3, it says, when we have a to the exponent of m or to the exponent of x, but also to another exponent of y. Imagine we're having 2 exponents on one base. So look at this. This is called law number 3. I want to talk about this because this is very important. Law 3. Let me use a different. Okay, let's call this law number 3. Okay, exponent that is raised to the power, raised to the exponent, actually more than one exponent. Here's the law. It says if you have a to the exponent of a, imagine we have this a to the exponent of x, everything to the exponent of y. How many exponents are we having here? Let's just look at them and try to analyze this. So the law says as long as you have multiple exponents on one base, you just take the base and you multiply the exponents. You multiply the exponent. So it will be just like this. So which means this will be just a times xy. So if we have this, what you do, you multiply the exponent, multiply the exponents. Because the base is the same, but you have multiple exponents. What you do, you just take the base and you multiply the exponents. Let's do an example. Imagine we have this. Imagine we have this. We have, it's just an example. Just imagine you have, let's say you have 2 to the exponent of 3, everything to the power of 2. So what does this mean? Let's just take it further. 3, it's an exponent. And even 2, it's also an exponent. But let's first deal with the exponent which is outside the bracket. What does this mean? It means this one is telling us how many times can we repeat this. So we have to repeat this 2 times. So it's going to be 2 to the exponent of 3 multiplied by 2 to the exponent of 3. So I'm repeating. This is telling me that how many times can I expand this? It will just be 3 times. Imagine when we had 2 to the exponent of 3 to the exponent of 4. It means I have to repeat 2 to the power exponent of 3 how many times? 4 times. So now you see that I've expanded to the exponent of 3 how many times? Twice. But since in between there's what? There is multiplication. It means I can use multiplication law, which is the same as when the base are the same, I take one base and I add the exponent, which is 3 plus 3, which gives us 2 to the exponent of 6. But how about this? You see, I've expanded to the exponent of 3 how many times? 4 times. 4 times. So here I expanded how many times? 2 times. So this is the same as, since we have multiplication in between, we know that the law of exponent says, as long as the bases are the same, we just take one base and add. This is 2 to the exponent of 3 plus 3 plus 3 plus 3. 3 plus 3 is 6. And 6 plus 3 is 9. And 9 plus 3, this gives us 12. So you see that, imagine when we have this. For now, it's easy. But imagine when we have this. Let's say we have 2 to the exponent of 3, but 100 times. So does it mean that we need to expand this 100 times? It will be a tedious work, because it's 2 to the exponent of 3 times 2 to the exponent of 3 times 2 to the exponent of 3 times 2 to the exponent of 3. Just how many times? 100 times, ladies and gentlemen. So do you think you will finish now doing this? The answer is no. So that's why we have to come up with this law that says, as long as the base, you have one base, but the exponent are many, what you can do, you can just multiply the exponent rather than solving one by one. So let us now start with the first one, this one. Since we have, I want to use the law, since we have 2 to the exponent of 3, everything to the exponent of 2. How many exponents are there? 2 of them. It's 3 and 2. So this we can just say, okay, let's take one base and we just multiply the exponent. Let's multiply the exponent. 3 multiplied by 2. And what is 3 multiplied by 2, ladies and gentlemen? 3 multiplied by 2, the answer just gives us 6. You see that we got the same answer as this. So it means from now on, for example, let's say we have this. We have 3, I'm going to say 2, this one. 2 to the exponent of 3 and also to the exponent of 4. What do we do? We just take the base and we multiply these exponents. 3 multiplied by 4. And what is 3 multiplied by 4? It's giving us 12. You see, that is the same as this, rather than expanding one by one. So you need to know the laws of exponents. Remember, practice makes perfect. So you need to be able to know the laws of exponents. Already we went through law 1, which is called multiplication law, which says when the base are the same for multiplication, you take one base and you add the exponent, always. It does not matter how many bases are there. As long as there are many, you can just take one base and add. Only when there is multiplication, not when there is addition. Then the second law is for division, which says as long as the bases are the same for division, you just take one base and you subtract the exponents. You know what is an exponent now, and you know what is a base. All right, let's talk about law number 4. Law number 4 is that one where we're going to talk about two bases. Okay, let me not say two bases because it might be more than one. Bases with the same exponent. The bases that have the same exponent. Multiple bases with same exponent. Let me just say bases with one exponent. One multiple bases, but they have with one exponent. This is law 4. It says when we have a times b to the exponent of n. You see, we have one exponent, but with multiple bases. Here we have two bases, a and b. A and b are the bases. So which means this is the same as a to the exponent of n multiplied by b to the exponent of n. So what we can do, we can just put the exponent in each base. So this is the law 4. Multiple bases that I have one exponent. So it means when we have multiple bases that are with one exponent, we can just put the exponent on each base. Why is this the case? Why is this the case? Okay. Okay, guys, just a minute. I apologize. Right, I was talking about the base where we have multiple bases, but the exponent is the same. So you can just put an exponent on each base. So a times b, everything to the power of n. The n is the exponent, is the one which is an exponent. So it means if n is an exponent, what you can do, you can just put an exponent in each base. For example, imagine when we have, it does not matter how many are they. Imagine when we have x times y, everything to the power of 3. According to this, it says this is the same as x to the power of 3 times y to the power of 3. Let's do an example and explain it. Why are they saying this? Imagine we have this. Let's say we have a times b to the exponent of 3. What is our exponent here? Our exponent is 3. So it means we can repeat AB how many times? 3 times. So we can say AB times another AB times another AB. So how many times did I repeat this? 3 times. But if you look at this, if you look at the A, we have A here, which means this is the same as say A times A times A alone, and also B times B times B alone. So it means you see that now, I will say, okay, fine. I already grouped the A's alone and the B's alone. So you see that this is the same as how many times can we write this A? So it will be 3 times. And this B 3 times. You see that is the same as just multiplying here. By how much? By 3. So from now on, we must know that once we have multiple bases that have the same exponent, we can just put the exponent in each base. Even if we have, let's say, x, y, z to the power of 7, it means this will be x to the power of z multiply y to the power of z of 7, sorry, and z to the power of 7. This is according to this law. I believe you are following. So 2 multiplied by 3 to the exponent of 4. This is the same as 2 to the exponent of 4 by 3 to the exponent of 4. I believe you are following. This is law number 4. Right. Then now, here I'm just introducing the law and doing some few examples. So which means I'll come up with an activity where we will have to solve these questions in the next video. Here I'm just introducing the laws. Now look at this. We have to move on to law number 4. It's law number 5, okay? Apologize. The law number 5, it says any number or a variable can be a number or a variable raised. A variable raised any number or a variable that is raised to the exponent of 0 equal to 1. Any number that is raised to the exponent of 0, it's always equals to 1. What does this mean? It means if we have a base of a, if we have a base of a, and we raise this base of a with an exponent of 0, I believe now you're following which one is an exponent and which one is a base. Remember here our exponent is 0. 0 is the exponent. The a is the base. So a raised to the power of 0, it means how many times can we raise this, the a? Obviously, it will be one time, because imagine how many times can we, so it means we have one time where we are erasing it. The answer will just be 1. Why are we saying any number at the power of 0 is 1? Let's prove this. Let's look at this. According to the way we know, look at this. What is 2 divided by 2? Obvious, 2 into 2 goes how many times? Once. But now look at this. Are you aware that with 2 divided by 2, this is also an exponent, because its exponent is 1, and also its exponent is 1 there. You see that since there is division, you can use division law. And what does division law say? It says when the base are the same for division, what do? You take one base and you subtract. And let's subtract what we have. 1 minus 1. And now what is this? 2 to the exponent. 1 minus 1 is what? 0. Remember, it means when we say 2 to the exponent of 0, same as 2 divided by 2. So which means we have proved that 2 divided by 2 is 1. It means even this one is also 1. So it means any number raised to the power of 0, it's equals to 1. It does not matter which, for example, even if we say x, y, z, everything raised to the power of 0. This will be 1, because if we were to use the previous law, law 4, it means this will be x to the power of 0 multiplied by y to the power of 0 and multiplied by z to the power of 0. And we know any number raised to the power of 0, it's 1. So it will be 1 by 1 by 1, which will just give us 1. So any number to the exponent of 0, it's always 1. This one is straightforward. This one is straightforward. Okay? So we went through law number 1, law number 2, law number 3. And now I want to talk about the last law by just looking at the example. Okay, I'll just write it here. Okay, law number 5. Sorry, it's law number 6. Sorry, this is law number 6. Law number 6 is where we are dealing with negative exponents. The negative exponent says when we have a, okay, let me use a black one, a raised to the exponent negative n. A raised to the exponent negative n. A raised to the exponent negative n. You see, our exponent is negative. According to this, it says a raised to the exponent of negative n is the same as saying 1 divided by a raised to the exponent of n. Why are we saying this is the same as a raised to the exponent of n? Look at this. Look at this. If we have the following, I want to explain to you so that you can understand. Imagine we have, look, we have 1 divided by 2 to the exponent of 3. It means this one here, this can be written as 2 to the exponent of 0. Why? Why are we saying it's 2 to the exponent of 0? It's because we know that any number to the exponent of 0, it's 1. Any expression or any variable to the exponent of 0, it's 1. So it means we can change this 1 because we want it to have a base of 2. It will be 2 to the exponent of 0. And you see what I've done? I've just, okay, fine. Because the bases are the same in terms of exponents, there's a division here. Do you know the law of division? The law of division says when the bases are the same for division, what do? Take one base and subtract. So this will be, take one base and subtract. So you're going to use this. Now the bases are the same. What are the bases? 2. Let's take one base and subtract. We're going to subtract, this is 0 minus 3. So you see that this gives us 2 to the exponent minus 3. So you see that if we look at this and look, this is minus n, but now it changes 1 over. You see that if we put 3 here and we put 3, it will be the same because it means this one and this is the same thing. So it means from now on, if we have, let's say we have 2 to the exponent of minus 3. If we do not want this exponent to be negative anymore, what do? We take it down. We just leave 1. We're going to have 1 divided by 2 to the exponent. So you change it to be positive. For example, if we say we have x to the exponent of minus 5, our exponent is negative. How can we change this to be positive? It means to take this as the denominator. So it will be 1 over x to the exponent of 5. So it means we leave the 1 here. For example, let's say we have 3 x to the power minus 7. You see, our exponent here is minus 7. And we no longer want it to be minus 7. We want it to be positive 7. So what do? We leave the 3 here. This will be 3. It's not 1 anymore. Divide by, we change the exponent, which is x to the exponent of 7. This is the law of, which is law number 6. So now, I want us to first go through all the laws, try to talk about them, because in the next session, I will be solving questions that are relating to exponents. And remember, exponents are important for all the grades. That's why this is still an introduction for grade 8 and 9. And what did he say about exponent? We said an exponent is the number of times a number or a variable is multiplied by itself. I think we went through that. And also we went through the notation of an exponent. We know which one is an exponent and which one is a base. We went through that. And we know the laws of exponents. The laws of exponent, we know them in solving problems. And again, okay, we defined what is an exponent. We went through the laws of exponent. So I actually wanted to repeat the laws of exponent so that everyone can be able to remember them, because we know which one is a base and which one is an exponent. And one other thing is the issue of, okay, just a minute, guys. Like, okay, fine. Let me just, okay, I wanted to erase this. Okay. Okay. So we know which one is an exponent, which one is a base. We went through that, the notations. So I want to talk about the laws of exponents again, just to remind everyone. But I will create a video where we're just solving questions that are related to exponents. So here I'm just introducing the laws only. Okay, let's talk about the laws of exponents. Okay, just a minute. Okay. Okay, let me talk about the laws of exponents. Law 1, we said for multiplication, when the base are the same, what do you do? Take one base and you add the exponents. Then law 2, when the base are the same for division, what do we do? We take one base and we subtract the exponents. Remember this, the dot is for multiplication. We can use brackets or we use a cross. And law 3, one base with multiple exponents, what do? We take the base and we multiply the exponents. Okay, law 4, multiple bases with the same exponent, what do? You multiply in on each base. So it's a to the exponent of x times b to the exponent of x. Then law 5, any number to the exponent of 0, it's 1. Then the law 6, it's for negative exponents. And what did you say about the negative exponent? When we have a to the exponent of minus x, this is the same as 1 divided by a to the exponent of x. So we change the exponent from being negative to positive. So it means it must be the denominator. For example, if you have 4 to the exponent of negative 10, I no longer want my exponent to be negative. What do? I just leave the 4 here. Then this one comes down, which is x to the exponent of 10. So we went through the laws, law 1, law 2, law 3, law 4, law 5, and law 6. And I think I went through some of the examples of exponents. So if you use these laws to solve problems, you never go wrong. All right, let's now move on to the how to solve exponential equations. All right, usually in terms of solving exponential equation, there is a property or a rule for solving exponential equation. Solving exponential equations. Right, let me talk about the law of the rule, which says, let's say you have a raised to the exponent of x. And this is equated to a raised to the exponent of y. Listen to me very well. Now we are talking about solving the equated. Right, you see that we're having a to the exponent of x. This is equated to a to the exponent. As long as there's an equal sign, and here we have a base. This is a base. The law says, this principle says, as long as the bases are the same and there's an equal sign, we just equate the exponent. So if a and b are the same as base, then it means now x is the same as y. X and y are actually equal. Why? Because look at this. If we say 2 to the exponent of 3, and here I put 2 to the exponent of this number. Which number can I put here? So that 2 to the exponent of 3 should be the same. Obviously, should be 3. Because 2 to the exponent of 3 is 8. And 2 to the exponent of 3 is 8. So which means, according to this, it says, as long as the bases are what? Are the same and like when we're equating, then it means the exponent are the same. And there's also another one which says, imagine now the bases are not the same. And we have a here and x, and there we have b and there x. You see, what is it that is the same here? Same exponent. So if the exponent is the same, it means even the bases are also the same. So we use this actually when we are solving equations, we are solving for x. Okay, let me give one example. Imagine in the exam, they say, solve the following exponential equation. You are solving exponents. Okay, here's an example. I'll just use simple example. Number 1, let's say they say solve for x, and you're given exponent. 2 to the exponent of x equals to 4. Obvious, to show this means, first of all, we need to look at the base. What is the base here? The base, it's 2. Here, this is also a base, but its exponent is 1. But the law says for you to solve this, you must ensure that the bases are what? Are the same. So it means you can change this to have the same base. How? Divided by 4 is the same as 2 by 2. And 2 by 2 is the same as 2 to the exponent of 2. So it means you can make this to say, okay, we have 2 to the exponent of x. And what is 4? 4 is the same as 2 to the exponent of 2. Now look at this. The bases are the same for equality. Now they have the same base. And what is the same base? 2. And since I said if the base is the same for equality, then you can just say, therefore, it means the x equals to 2. And you can prove, you say, let me go and check let me go and where there is x, let me put 2. So you see that where there's x, when you put 2, what is 2 squared? 2 squared is 2 times 2, and the answer becomes 4. We see that is the same. For example, let's say number 2. 3 to the exponent of x equals to 9. You see, the base is 3 and this side is 9. So we can expand 9 as, remember 9 is the same as 3 times 3. And 3 times 3 is the same as 3 to the power of 2. So it means we can expand these as 3 to the power of 2. Now the bases are the same for equality. It means therefore x equals to 2. You can check. As we do this only for equality. Number 3. 3, let's say 2 to the exponent of x equals to 32. 32, we can write 32 to have a base of 2. 2 times 2 times 2 times 2 times 2. How many 2s are there? 5. So 2 times 2 times 2, 5 times, what is that? Obviously, it's 32. You see that is the same as 2 to the exponent of 5. So we can write 32 as 2 to the exponent of 5. And now the bases are what? Are the same. Then we can therefore x equals to 5. That is how we solve equations. We can do another one. Let's say we have 4 to the exponent of x equals to 16. What is our base here? 4. And the base there is 16. But we can write 16 to have a base of 4. Why? Because 4 times 4 is the same as 16. And 4 times 4, how many times do you repeat this? 2 times. So this is the same as 4 to the exponent of x. 16 the same as 4 to the exponent of 2. Now the base are the same. So we can say x equals to 2. I believe you are following. This is how we are solving exponential equations. Only you do this when they say solve for x. So you need to ensure that the bases are the same for equality. Then since the bases are the same, it means even the exponent should be the same. Another way would be, imagine we have this, x to the power of 3 and 3 to the exponent of 3. Look at this. We want to solve for x. Now what do we have? We have a base. Our base is x. And there's an exponent. Even here, this is an exponent. This is the base. You see, the exponents are now the same. And what we want is the base. Obviously, if the exponent is the same, it means even the base should be the same. X should be 3. And to prove this means where there is x, if we have x to the power of 3, let's put 3. 3 to the exponent of 3 is the same as this. You see, it's 27. For example, let's say you have x to the exponent of 3 equals to 81. X to the exponent of 3 equals to 81. Let's use another one. Let's say 64. Let's use 64. So we want x, which is the base, is going to be x to the exponent of 3. 64 is the same as 4 times 4 times 4. Or we can use 2, but let's use 4. 4 times 4 times 4. 4 times 4 times 4 is 64. But how many times is this? 3 times. So it's 4 the exponent of 3. Now you see that the exponents are the same. Obviously, if the exponent is the same, it means even the bases are also the same. But we'll do an example based on this. We'll do an example. So we'll also create a video where we're solving questions now, because now you understand the laws. So you only do this when you have an equal sign in between. So what you do, you need to make sure that the bases are the same. And for you to be able to know this, you need to be able to know the multiplication of numbers. So when I'm saying multiplication of numbers, I'm referring to, for example, if we have, we know 4, the perfect square number 4 is the same as 2 times 2, which is just 2 squared. Then 8, it's 2 times 2 times 2, which is 2 to the exponent of 3. 16, we can say, is 2 times 2 times 2 times 2, which is 2 to the exponent of 4. Or we can just say 4 times 4, which is 4 squared. It's one the same thing. 81 is the same as 3 by 3 by 3 by 3, which is 3 to the exponent of 4. Or we can just say 9 by 9. But you see, 9 is the same as 3 by 3 by 3 by 3. You see, is the same as that. So it's very important to know this. For example, 64 is the same as 2 times 2 times 2 times 2 times 2 times 2, 6 times 1, 2, 3, 4, 5, 6. So this is 2 to the exponent of 6. Or we can just say this is the same as 4 to the exponent of 3, because this 4 and this 4 and this 4. Or we can say it's 8 by 8, which is 8 squared. So it depends with the question. So it's very important to know this, guys. This is for both grade 8 and 9. Exponents are very important. So I will create a video where we're just going to solve questions of exponent. Here I was just introducing the law. Law number 1 for multiplication, that when the bases are the same, you take one base for multiplication and add the exponents. For division, when the bases are the same, you take one base and you subtract the exponents. And the law number 3, it says when you have one base but with multiple exponents, you can just multiply those exponents. And law number 4, it says when you have multiple bases with the same exponent. Okay, what do I say about, okay, multiple bases with the same exponent, you just multiply each. All the base should be raised to that exponent. And any number to the exponent of 0, it's always 1. And also the case of dealing with negative exponents. Because sometimes in the exam, they can say, simplify the following. Then they want you to use the exponents. For example, if you have x to the exponent of 5 times x to the exponent of 2 times x to the power exponent of 1. How do you simplify this? In between, there is multiplication. The law says wherever there's multiplication, you just take one base and add. So it's 5 plus 2 plus 1. This will be x to the exponent of 8. And when we have x to the exponent of 5, sometimes it's possible to find that you can use multiplication and division at the same time, but we'll talk more about that. Let me not complicate you. You just go through all the laws on your own, understand what I've just done here. It will be easier for you to solve the questions in the next video. So this is the end of the session, ladies and gentlemen. Thank you very much. Kindly don't forget to like, subscribe, and share. Bye-bye.